Okay, let's talk about series. If a sequence is just a list of numbers, a series is just a list of numbers with plus signs in between them. It's what you get when you add up a list of numbers. So let's give an example of a series would be something like 2 plus 4 plus 8 plus 16 plus 32. This is an example of a series. It has 1, 2, 3, 4, 5 terms. And this happens to be a series where the terms have a nice relationship. We called it a geometric series before. Each time you move from one term to the next, you multiply by 2. Not all series are like that. And just like sequences, you'll find that some series, the pattern is easy to identify, and some is trickier. Okay, when we write these guys down, there's a nice shorthand for writing down series, which is the notation known as sigma notation. Sigma is a Greek letter. It looks like this. And it means sum. Sum is just what you get when you add things up. And the general idea of sigma notation is we write as follows. I equal 1 to k of ai. AI is just the ith term in the sequence. I'm using I as my index instead of n here. Don't let that throw you. It means the same thing. So there's going to be A1, A2, A3, A4. And the top and bottom of this sigma, this is a Greek letter, sigma, the bottom I equal 1 tells you the first number to put in here for I. So A1, that's going to be the first one. And then it goes up to some number k. So A1, A2, this thing is equal to, well, first we put in 1 is A1, then we put in 2, A3, plus dot, 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 plus, and we go up as far as k. So this is the shorthand way of writing something like this. We'll see this in practice, but it's important to know that when you see this nice compact thing, it's really talking about a much larger expression. It's adding a whole bunch of things up. Let's see it in action. So, A. This is the sum, I equal 1 to 4, of AI, where AI gives as a definition is 7i plus 3. So, to find what this sum is equal to, well, I can tell you right now what it's going to look like. So this thing is equal to, we're going to substitute 1, 2, 3, and 4 into here, and I'll just write them as A something for now. A1 plus A2 plus A3 plus A4. We're going to be adding up 4 numbers, and we're going to find those 4 numbers by using the formula here, substituting in first the number 1 in, and then the number 2 in, and so on, as follows. So A1 is equal to 7 times 1 plus 3. I'm just going to stick that in here. 7 times 1 plus 3. Plus A2 is equal to 7 times 2 plus 3. Plus A3 is 7 times 3 plus 3. And then plus A4 is 7 times 4 plus 3. And then it's just a matter of multiplying, simplifying, adding all these things up. Since the parentheses are only connected by addition, we can just drop the parentheses. We get 7 plus 3 plus 14 plus 3 plus 21 plus 3 plus 28 plus 3. And then it's just a matter of arithmetic. We have to add all of these guys up. If you have a calculator, you can do it that way. If you want to do it in your head, go for it. You're going to see, if you want to put together all of the 3s, there's a 3 and a 3 and a 3 and a 3. That's 4 3s, which is 12. And then we also have to add 7, 14, 21, and 28. Put all of those together, and we get a total of 82. So, this sum, I equal 1 to 4 of AI, is equal to 82. All right, that's it for problem A. Go ahead and take a look, give problems B and C a try on your own, see what you can do with them, and then come back and we'll do them together. Here we go. All right, part B. Let's grab a copy of it. So what we're trying to find is, whoopsie, the sum, j equal 1 to 6. They're using a different letter now for the index. That's just to get you used to trying out different letters. The important part about that j is that it's the thing that appears as the index, is the little subscript on the letter here. So you know that that is j is the thing that you're talking about plugging into each term. So this is j equal 1 to 6 of aj. And we have the formula an is equal to minus 2 to the n. Now here they use the variable n. All right, does it matter? No, this is just, if you want to know a1, put 1 in here. If you want to know a2, put 2 in here. And this expression, what does it mean? It means, well, it means a1 plus a2. We're starting, remember this says start at 1 and go up to 6. I'm not done yet. Plus a2 plus a3 plus a4 plus a5 plus a6. Now, do we have to do this by hand? No, we don't. For example, you can do it on the TI-84 calculator. You can also do it in a lot of different computer algebra systems. We'll work through it by hand, but if you have a shortcut way that you'd like to do it to try to check your answer, that's just fine. So let's just find out what each of these are. For a1, we're going to plug 1 in here, and it's going to be minus 2 to the power 1. Oops. All right, so this is a1 is negative 2 to the 1, plus a2 is negative 2 to the power 2. a3 is negative 2 to the 3, and so on. a4, a5, and a6. Let's go ahead and calculate these guys out. Negative 2 to the power 1 is negative 2. Negative 2 to the power 2 is positive 4. Negative 2 to the 3 is negative again, it's minus 8. And then it's going to go plus 16, minus 32, plus 64. Okay. And then we go ahead and add these things up. Let me see, minus 2 plus 4, that, let me just switch colors here. So these two give me a total of positive 2. These minus 8 and 16, they add up to 8. And these ones, minus 32 and 64, they add up to 32. And then if I just add those three together, 2, 8, and 32, I can get my final answer, which is 42. So this thing, the sum of this series, j equal 1 to 6 of aj, where an is given by negative 2 to the power n, that sum is equal to 42. All right, let's take a look at our part C. Now, in part C, they've thrown one more bit of notation at us, which is just, instead of writing the sum from 1 to 5 of a sub something, and then giving a separate formula for a sub something, they just never mention the a. They just put the formula for ak right in here. So the way to think of this parentheses is this is like ak is equal to this, 4 plus k squared. And we're taking the sum k equal 1 to 5 of those terms. And basically, what does it mean? It means that you would substitute first the number 1 into this expression, and then plus, and then substitute the number 2 into this expression, and then plus, substitute the number 3 in here, and keep going until you reach 5. So that's the strategy that we will do here. You'll see it's just essentially one step shorter than the work we were doing before. So k equals 1 to 5. So we're going to start with k equal 1. When k equals 1, we get a term that looks like this, 4 plus 1 squared. Then, plus our next term. Our next term is when k is equal to 2, so that's 4 plus 2 squared, plus 4 plus 3 squared, plus 4 plus 4 squared, plus 4 plus 5 squared, whoop, got my parentheses, and plus 4 plus 6 squared. Once again, you can calculate this using a calculator. You can do it by hand. What you're going to come up with in the end, however, is all of this is equal, if we simplify it, to 75. All right. That's our basic introduction to series and just a little bit of experience in finding the sum of a series. You can imagine that if we asked for this sum to go, instead of from 1 to 5, we went from 1 to a much larger number, 1 to 1,000. This would become quite difficult to calculate because it's just so many numbers. It'd be really easy to make a mistake. You would want to use a computer to do it or some other insight, some shortcut way of getting to the answer. And that is not always possible with series, but for certain series, it is possible. And that's something we'll be looking at a little bit later in the lesson.